This is Euclid Book 8, proposition number 19. And it says, between two similar solid numbers, there fall two mean proportional numbers. And the solid number has to the similar solid number the ratio triplicate of that which the corresponding side has to the corresponding side. Wow. Okay. Let A and B be two similar solid numbers. Well, here's A and here's B right there. And let C, D, and E be the sides of A. C, D, and E. Now, I would reckon that when they're talking about the sides of a magnitude like this, they're probably talking about in the same way a few proofs ago where they were talking about sides again. At that point, it was sides of a square. I think these are sides of a rectangle or some other polygon. I'm not really sure what. And FGH of B. So we have FGH, and they're the sides of B. Okay. Now, since similar solid numbers are those which have their sides proportional, this is by Euclid Book 7, definition number 21, therefore, as C is to D, so as F is to G. Okay? And as D is to E, so as G is to H. Okay. I say that between A and B, there fall two mean proportional numbers, and A has to be the ratio triplicate of that which C has to F, D, to G. Okay, whoa. And A has to be the ratio triplicate of that of which C has to F, D has to G, and E has to H. Okay. So as A is to B, that ratio is triplicate that of C is to F, D is to G, and E is to H. Okay. For let C by multiplying D, so C times D is going to make K. C times D makes K. And let F by multiplying G makes L. F times G makes L. Now, since C and D are in the same ratio with F and G, so as C is to D, so as F is to G, and K is the product of C and D, so C times D makes K, and L is the product of F and G, so F times G makes L. K and L are similar plane numbers by Euclid Book 7, definition number 21. Therefore, between K and L, there is one mean proportional number. This is by Euclid Book 8, proposition number 18, which we covered in the last video. Let it be M. So M is the mean proportional between K and L. Therefore, M is the product of D and F. D times F equals M. As was proved in the theorem preceding this, which is Euclid Book 8, proposition number 18. Now, since D by multiplying C, so we're going to take these two times each other, has made K, and D by multiplying F has made M. Therefore, as C is to F, so is K to M. As C is to F, so is K is to M, and this is by Euclid Book 7, proposition number 17. But as K is to M, so is M is to L. As K is to M, so is M is to L. Therefore, K, M, and L are continuously proportional to the ratio of C to F. Okay. As C is to F, so is K is to M. As K is to M, so is M is to L. And since as C is to D, so as F is to G, as C is to D, so as F is to G, alternately, therefore, as C is to F, okay, so as D is to G. This is by Euclid Book 7, definition number 13. Sorry, that's by Euclid Book 7, proposition number 13. For the same reason also as D is to G, as D is to G there, so as E is to H. Okay, as D is to G, so as E is to H. Therefore, K, M, and L, K, M, and L are continuously proportional in the ratio of C to F, in the ratio of D to G, and also the ratio of E to H. So as K is to M, so as M is to L, so as C is to F, so as D is to G, and so as E is to H. All right. Next, let E and H by multiplying M make N. Okay. Oh boy. E times M makes N. E times M makes N. Okay? And E times, no, I'm sorry. And H times M makes O. H times M makes O. You try keeping track of all this. Now, since A is a solid number, and C, D, and E are its sides, therefore E, by multiplying the product of C and D, has made A. Okay. Whoa. What they're saying is that first you multiply C and D. C times D. Whatever answer you get from that, you multiply that by E, and you will get A. But the product of C and D is K. So we said C times D equals K. Therefore, E, by multiplying K, has made A. E times K makes A. For the same reason also, H by multiplying L makes B. So now we're going to say that H multiplying L gets B. Now since E by multiplying K has made A, and further also by multiplying M has made N, okay, so now we're going to say E times K makes A, and E times M makes N. Therefore, as K is to M, so as A is to N. And this is by Euclid Book 7, proposition number 17. But as K is to M, so as C is to F, so as D is to G, and also E is to H. Therefore, also as C is to F, and D is to G, and E is to H, so as A is to N. Okay, you're saying, well, I want to demonstrate this. As K is to M, so as C is to F, so as D is to G, so as E is to H, so as A is to N. Again, since E by multiplying M has made N, E times M makes N, and H by multiplying M, okay, H by multiplying M has made O. Therefore, as E is to H, as E is to H, okay, as E is to H, so is N to O. This is by Euclid Book 7, proposition number 18. But as E is to H, so is C is to F, and D is to G, and I'm sure you can trace all this stuff out. Therefore, also as C is to F, so is D is to G, so and E is to H, so A is to N, and N is to O. All right. Let's do it this way. As C is to F, so as D is to G, so as E is to H, so as A is to N, and N is to O. Did you follow all that? I'm glad. Again, since H by multiplying M has made O, okay, H multiplies M makes O. And H times L makes B. H times L makes B. Therefore, as M is to L, so is O is to B. This is by Euclid Book 7 Euclid Book 7 proposition number 17. But as M is to L, so is C is to F, so is D is to G, so is E is to H. Therefore, also as C is to F, so is D is to G, so is E is to H. So not only is O is to B, but also A is to N, and N is to O. Therefore, A, N, O, and B are continuously proportional in aforesaid ratios of the sides. Wow. Now we get into the real heart and soul of the proof. Oh, you thought you were done, huh? No. I say that A also has to be the ratio triplicate of that which the corresponding side has to the corresponding side, that is, of the ratio which the number C has to F, or D has to G, and also E has to H. For since A, N, O, and B, well, here's A, here is N, here is O, and here is B, are four numbers in a continued proportion. Okay? So as A is to N, so is N is to O, so is O is to B. Therefore, A has to be the ratio triplicate of that which A has to N. This is by Euclid Book 5, definition number 19. But as A is to N, so it was proved that C is to F, and D is to G, and also E is to H. Therefore, A also has to be the ratio triplicate of that which the corresponding side has to the corresponding side, that is the ratio which the number C has to F, and D has to G, and also E has to H. What a proof, huh? Alright. That's it. I will tell you more in my next video. Stay tuned.